Welcome everyone to this explainer. Today, we're doing something really fun. We're diving into the structural elegance of building interactive command line interface, or CLI applications in Python. You know, we spend so much of our time interacting with these highly polished, beautiful graphical interfaces, right? But at their core, those big applications are actually built on the exact same foundational logic we're about to explore today. We're going to completely break down the architecture of a Python quiz application. We'll focus heavily on that magical transition from a static, boring script to dynamic, interactive state management. Because the moment a script stops just running in a straight line and actually starts waiting, validating, and responding to user input, that's when it fundamentally transforms from a basic set of instructions into a truly robust application.
So let's think about this for a second. How does a computer actually grade your quiz? Think about the hidden complexity behind a totally simple terminal prompt. When you submit an answer, what's literally happening inside the system's memory? Scoring a quiz isn't just about throwing a check mark next to right or wrong. No, it requires secure data retrieval, strict input sanitization, and continuous state persistence the entire time the program is running. The system has to capture your keystrokes, normalize that data type, securely compare it against a hidden answer key, and mathematically evaluate the whole state of the app, all in mere milliseconds. We're going to look at the exact algorithmic thinking you need to construct this kind of loop.
All right, here's our roadmap for this explainer. We've got 5 distinct phases. First, the quiz app blueprint. Second, storing questions and answers. Third, powering user interaction. Fourth, calculating the final score. And finally, assigning the final grade. Let's get into it. Starting right off with Section 1, the quiz app blueprint.
Now, before any complex data sorting or heavy mathematical evaluation even kicks off, the script simply executes a very straightforward print statement. It outputs a formatted header directly to the standard output. And you might be wondering, why bother? Well, in CLI development, your user experience is hugely dependent on immediate terminal feedback. When an app launches in a console, users need instant visual confirmation that, hey, the execution was actually successful, and the process hasn't just stalled out in the background. Putting up this visual boundary basically draws a line in the sand, explicitly showing exactly where the user's standard terminal ends and our interactive application loop begins.
Moving right along to Section 2, storing questions and answers. For our core data architecture, the application uses a Python dictionary. It's essentially our highly organized digital filing cabinet. When you have to decide how to store linked data, like a question prompt, its multiple choice options, and the correct answer, a dictionary is absolutely the optimal choice. Why? Because it gives us what computer scientists call O1-time complexity for lookups. Basically, it's practically instant. Instead of forcing the computer to painstakingly scan through parallel lists or arrays to find the right data, we just use the question string itself or maybe a unique hash ID as our primary key. That key points directly to our payload. Structuring it this way keeps our memory footprint super light and guarantees data retrieval is lightning fast, which is absolutely crucial, even for smaller apps. Now, nested safely inside that dictionary payload, we manage the multiple choice options using a list. Lists are ordered, mutable data structures, and in the context of a multiple choice quiz, deterministic rendering is a non-negotiable requirement. Think about it. We need the absolute guarantee that options A, B, C, and D are going to be indexed and displayed in the exact same sequence every single time the Python interpreter reads them. By combining the rapid, instant lookup of a dictionary with the strict, ordered sequence of a list, we've just built an incredibly reliable data model to run our front-end display.
And this beautifully illustrates exactly how our architectural setup cleanly separates the front-end rendering data from our back-end validation data. You can see the prompt and the options are deliberately designed to be pushed out for the user to read, but that correct answer string, that remains strictly isolated for our back-end logic. By structuring the data block in this unified way, we ensure the validation logic is never accidentally exposed to the client side too early. The actual answer key just sits securely in the system's memory, only pulled up at the exact split second of conditional evaluation, and then it's immediately dumped from the active scope.
Okay, Section 3, powering user interaction. This is the engine of the whole thing.
To actually transition into the application's active state, we have to initialize a variable. Specifically, we declare a score variable and give it an integer value of 0. Now, the absolute critical software engineering principle we have to talk about here is variable scope. This initialization has to happen in the global scope, or at least the main function scope, strictly outside of the upcoming interaction loop. If you make the mistake of initializing this variable inside the loop itself, it'll either reset back to 0 on every single question, totally wiping out the user's progress, or it'll throw a nasty unbound local error and crash the program. Properly scoping this little 0 ensures our state persists across the entire lifespan of the app.
So to actually run the quiz, the application kicks off a for loop, iterating methodically through our dictionary. A massively efficient way to do this in Python is by using the .items method. This method brilliantly unpacks the dictionary key and its values at the exact same time, which minimizes memory overhead and keeps the namespace super clean during each cycle. On every iteration, the script dynamically prints out the prompt, drops in the ordered list of options, and then deliberately freezes. It just suspends execution at standard input. The program literally yields control over to the operating system, just sitting there in a suspended state, patiently waiting for a keyboard interrupt from the user.
But here's the catch. Handling unpredictable human input is a core pillar of keeping an app stable. A user might type a lowercase b when your backend validation key is strictly looking for an uppercase b. To a computer interpreter, those are two totally distinct ASCII characters, which will trigger a false negative and mark a right answer as wrong. Our code fixes this by using the .upperString method to instantly normalize the input. In major production applications, developers will actually chain this with other methods, like .strip, just in case a user haphazardly hits the spacebar before hitting enter. Sanitizing these inputs right at the boundary line is exactly what prevents weird edge cases from breaking your logic further down the line.
All right, Section 4, calculating the final score.
Once the loop finally finishes and terminates, the app jumps into its final state evaluation. By dividing the final integer value of score by the total length of the dictionary keys, Python performs standard division. Now in Python 3, dividing two integers naturally spits out a floating point number. We multiply that float by 100 and boom, we scale it to a standard readable percentage. But developers have to be careful about data formatting here. If you don't use a function like rounding or set up formatted string literals, a score of, say, 5 out of 6 could result in printing a ridiculously long float like 83.33333% directly to the terminal. And let's be honest, that just looks messy and really degrades the polished feel of your user experience.
Finally, Section 5, assigning the final grade. The application takes that raw percentage we just calculated and translates it into a final output using a top-down control flow structure. Specifically, we're using if, elif, and else statements. Listen, the execution order in this block is absolutely paramount. Python evaluates these conditions sequentially, straight from the top down. If we accidentally inverted this logic and checked for a score of, say, greater than 40% first, a user with a brilliant 95% score would hit that very first block, evaluate as true, the flow would terminate early, and the app would incorrectly slap them with a grade C. Structuring conditional flow means you have to meticulously map the logic from the most exclusive, highest condition, all the way down to your ultimate fallback, the else statement, to guarantee the evaluation is exhaustive and accurate. So what began as just a static dictionary of plain text was completely transformed through optimized lookups, state persistence, input sanitation, and strict control flow into a highly deterministic, fully functional application engine. Understanding this internal logic of a simple CLI quiz actually gives you the foundational architecture to build far more complex systems. The real question for any developer now is, how would you scale this blueprint? Would you ditch the hard-coded Python dictionary and plug in a persistent SQLite database for dynamic querying? Or maybe you abstract the command line interface entirely and wire this core validation logic into a slick tkinter graphical interface or a Flask web front end. The architecture remains exactly the same, but the execution is entirely up to you. Thanks so much for joining me for this explainer, and I'll catch you next time.